Hey there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our fifth video on graph transformations. Let's start with something we already know. Now, we have previously talked about the following types of graph transformations. Assume I start with a graph f of x. I want you to try and remember what happens if you draw the graph a multiplied by f of x in the case where a is bigger than 1 and the case where a is between 0 and 1. Pause the video and double check you can remember how to do that. Okay, you should have remembered the following. Okay, when you're multiplying by a, and a is a number bigger than 1, it's a stretch in the y direction by a factor of a. All the y values are multiplied by this number a. If a is less than 1 and bigger than 0, you end up squashing, you can think of it, your original graph in the y direction again, and the other way you can think of it is all your y values are divided by a factor of a. Now we're going to talk about something very similar in this particular video. We're going to talk about what happens when you do graph transformations of the form negative f of x. So what we're looking for is something like this. Suppose we had a function f of x. We're interested in what happens to the graph if you are trying to draw the graph negative f of x or negative a lots of f of x. So really it's very like what we've already done if you think about it. In this case we're just multiplying by negative 1, and in this case we're multiplying by negative a. So it works similarly to our graphs of a f of x. Let's get the graphing software out and just see if we can spot what's going on here. So here's the graphing software, and I've got a function for you there. So there's a function, and I've got its turning point or its minimum is 3 across 1 up. Now I'm just going to draw negative f of x. And what do you think has happened there? Can you see what's happened? Well, we have multiplied all the y numbers by negative 1, and the result of that is we have reflected the whole graph in the x-axis. Okay, it has been reflected in this line acting as a mirror. Why is that? Well, for example, 3 across 1 up, the coordinate 3, 1, well, the y number's been multiplied by negative 1, so the turning point for the transform graph is going to be at 3, negative 1. And similarly, any y value along this graph here has been multiplied by negative 1, resulting in it being a reflection in the x-axis. Now, if I was to not just draw negative 1 f of x, but if I was to draw negative a lots of f of x, okay, and you can see here that a similar thing happens to what we've been doing before. Say if I was made the number negative 3 f of x, well, what am I doing? I'm multiplying all the y numbers by negative 3. So you can see here that 3 across 1 up turned to 3 across 3 down. If I multiply all the numbers by, let's say, negative 7, what was 3 across 1 up is now 3 across 7 down. So you can think of it as two things going on here. The multiplying by a negative reflects it in the x-axis, and then the multiplying by the 7 does the whole thing we talked about previously. It stretches it in the y direction by 7. It multiplies all the numbers by 7. So let's go back to our lesson and see if we can formalize what's going on here. Here's a graph f of x. What happened with negative f of x? Well, we multiplied all the y values by negative 1, which resulted in a reflection in the x-axis. And similarly here, we have a similar thing here, other than also we're having some sort of stretch in the y direction going on. So the graphs would look something as follows. So say if this point here, this is a turning point of the original f of x graph, if that has turning point at 3, 1, this one is going to have turning point at 3 across but 1 down. We multiply the y number by negative 1. Now just say, for example, this again has turning point 3, 1. This one, if we're multiplying the whole graph by negative a for some number a, this one's going to keep the same x value, but we're going to multiply this 1 by negative a. It would be down there. Okay? So as well as it having a reflection in the x-axis, it's also being stretched in the y direction by a factor of this a. So we better summarize that with some words here. If we're multiplying by negative 1, what is the outcome? Well, we are reflecting graph in the x-axis. And practically what happens is you multiply all the y values, you get multiplied by negative 1. And here we are having a reflection of the graph in the x-axis, and we're having some sort of stretch, and I'm just going to write what happens really. The y values are all multiplied by negative a, assuming of course a was a positive number in the first place. So that's our learning from this particular video. Let's get on and do some questions. Pause the video and have a think about this one. So we're given a graph of the function f of x. We're asked to draw the graph of negative f of x. So remember what negative f of x means. You're multiplying all the y numbers by negative 1. It's a straight reflection in the x-axis. And I'm going to write in brackets because sometimes it's easier to think of it like this. You multiply all y's by negative 1. So let's pick the key values on this graph. This here is 0, 0. This here is 90 across, 1 up. This here is going to be 180, 0. This here is 270, negative 1. And this here is 360, 0. All I'm going to do in each of these cases is multiply the y number by negative 1. 0 multiplied by negative 1, still 0. We've got a point there. 1 multiplied by negative 1, that's going to be down here. 0 multiplied by negative 1 still there. Negative 1 multiplied by negative 1's up there, and the other one's there. And as you can see here, I'm going to join these up. You can see, as we talked about, the blue curve has been reflected in the x-axis. It's done exactly what we thought before. And I'm going to put in the key points here. This here is negative 90, negative 1, and this point here is 270, positive 1. And the red line shares the same 0, 0, 180, 0, and 360, 0, and we're done. Okay, another question. Pause the video and have a think about this one. Okay, the diagram shows a function f of x, which is given to us. We're asked to sketch on the same diagram the graph of negative a half f of x. So two things are going on here really. On the one hand, you can think of it on the one hand as having, yes, we have a reflection in the x-axis, and also the fact that we're multiplying by that half, we're also having a squash, you can think of it, in y direction by a half. Okay, so in one move you can think of it though as you're multiplying all the y numbers by negative a half. That's another way of thinking about it that will help you do that. So let's mark off the key points here. This here is 0, 0. This point here is 94. This point here 180, 0. This point here 270, negative 4. And this one here 360, 0. Okay, what we're going to do, we're multiplying all the y values by negative a half. 0 multiplied by negative a half is still 0. Now 4 multiplied by negative a half is negative 2. So 90 goes with negative 2 down here. Again, it shares a point there. Negative 4 multiplied by negative a half is positive 2. So we're going to get ourselves up here, and then we're going to get ourselves here. So joining the dots, we have our graph of negative a half f of x as required. Okay, and again you can see that we've multiplied all the y values by negative a half, but you can also see geometrically what's happened. We've had a reflection for sure, and we've had a squash by a factor of 2 as well. Let's try another one. Pause the video, have a go. Okay, we're given the graph of f of x. We're told it has a turning point at 3 across 8 down, which we'll label in. We're asked to state the turning point of the following graphs, negative f of x. Remember, all you're doing is multiplying all the y numbers by negative 1. Its turning point, therefore, will be at 3, positive 8. What about this case? Again, all you're doing is multiplying the y numbers by negative 3. So it's going to be 3, negative 8 multiplied by negative 3 is positive 24, and we're done. And that's it for this particular video. Thanks loads for watching.